Numerical aperture. To understand numerical aperture, there are a few core concepts about fiber optics that first need to be understood, such as the structure of fiber optics, what an incident ray is, what the angle of incidence is, and what total internal reflectance is. Firstly, we will discuss the structure of fiber optics, and we've already covered this topic in depth in our video, The Structure of Fiber Optics, but let's go ahead and quickly summarize. Typically, fiber optic cables are made up of a glass or plastic core surrounded in cladding made of a less reflective glass or plastic, and then surrounded again in a nylon jacket. This is the general structure, as some fiber optic cables may offer multiple cores within a single cable. They incorporate Kevlar strands into the structure to provide greater strength and use as an armored coating, such as glass or corrugated steel tape to protect against rodents and other creatures. The incident ray is a ray of light that strikes a surface. When talking about fiber optics, this is the light inside the fiber's core hitting the cladding, and the angle of incidence is the angle of the incident ray in relation to the perpendicular cladding surface. Total internal reflection occurs when the light traveling down the fiber core strikes the cladding and is reflected back into the core in such a way that this process is able to continue as far as the light ray can travel. After looking at these core aspects of fiber optics, we can now explore numerical aperture. Numerical aperture of a fiber optic cable is the sign of the greatest angle an incident ray can have to achieve total internal reflection. When we look at this in real-world applications, this relates to the overall cone of light that can be accepted into the fiber optic cable as we take the numerical aperture and apply it 360 degrees around the cable end face, giving us the cone of light that will be accepted into the cable.